of mass. It is a point at which total mass of an object seems to act on it. It is the definition for the center of mass. Now let's see with the examples how do we find the center of mass for regular and irregular shaped objects. The regular shaped objects, an example is a rectangle. So how will we find the center of mass? We draw two lines like this, and two lines intersect at a point. Two lines intersect at a point. The point of intersection is known as center of mass. The another name, center of gravity. What is center of gravity? Just you have to replace here the mass to weight. It is a point at which total weight of an object seems to act on it. So it is center of mass or center of gravity, the point. Okay, now how will we find a center of gravity for another regular shaped object? A circle, it's not regular completely. How will we find the center of gravity? Now first we have to draw a line, a tangent line. We just pass through a point. Just pass through a point. It should not cut the line, cut the circle, just pass through like this. So if you have a ruler, you can draw nicely. Okay, then you connect these two corners and here these two corners, and you can get more accurate center of gravity or center of mass. Okay, another regular shaped object. So triangle. How will we find the center of gravity? You draw a line from here to this point which makes 90 degree, and from here draw to the base should make 90 degree, and draw a line from here and it makes 90 degree. And here is the point, center of gravity is here. Three lines intersect at a point, center of gravity. So minimum two lines is enough. Minimum two lines are enough to find center of gravity. Like here is one line, and this line is enough. Just we need to get a point of intersection. So minimum two lines. So if you draw a third line, you get more accurate center of gravity. We are going to find the center of mass for irregular shaped object. Now you cut an irregular shaped object from a cardboard in this shape. It is irregular shape now. Now I want to find a center of mass for this cardboard, irregular shaped cardboard. And first I want to give the name for this. It is called a lamina. I have to cut three holes, and it should be far apart, far from each other, and it is labeled A, B and C. And I have to insert this cardboard through the hole A in the stand. Here is a clamp. Here is a clamp, and it is clamped through the hole A. And next step, what you have to do, you have to flick the cardboard and check if it is swinging freely, to check if it is a friction or not. If there is a friction, you cannot get the accurate center of mass or the center of gravity. What we have to do, make the hole bigger. So if the lamina, irregular shaped lamina is swinging freely, then next step we have to attach a plumb line. We have to attach a plumb line, and this is called a plumb line. What is plumb line? Just like a simple pendulum, you can assume the simple pendulum as a plumb line, a thread and with a mass. Thread with a mass attached. Now this line, this blue line, is passing through somewhere through the center of mass. So I want to trace this blue line, the thread, trace the thread. So what I have to do, I have to mark behind the thread onto the lamina, irregular shaped lamina, two dots like this, far apart, far apart. It shouldn't be closer. It shouldn't be closer here like this. The two dots should be far apart. Then remove plumb line and remove the card from the clamp, and you connect the two dots by a straight line. So now you will get a line on the cardboard like this, and repeat the same process through the hole B and C. So if you do that, you will get a line like this, another line like this. So now we found more accurate center of mass. So if it is the plane irregular shaped lamina, and somewhere some point will be known as or assumed as a center of mass or center of gravity. We can find a center of gravity in this method. It is a small experiment. You can do it and can find. So if you find a center of gravity, how to check if it is the right point? You can use your finger to lift the cardboard, the plane irregular shaped lamina. It is balanced. If it is so, our point is more accurate, right? Now I am going to find the center of mass for L-shaped object. L-shaped. How do we find this L-shaped object center of mass? First, I want to split this L-shaped into two shapes, a rectangle and another rectangle. And here I find the center of mass by drawing like these two lines. And here I found a center of mass for the first rectangle. And then I want to find another center of mass for this bottom one. You can draw more accurately using a ruler. Okay, sorry for the diagram. And here is another center of mass for the rectangular shape too. Now what I have to do, I have to join these 2 points. I have to join these 2 points. And if the line, you have to measure this line, you have to measure this line. If the line is 4 centimeter, at the middle 2 centimeter will be the center of mass. In this way you can find the center of mass for L-shaped object. If we know the center of mass, the concept, then we can guess the center of mass for any object if we know the shape and how the mass is distributed. And here is a shape, irregular shape here in this diagram, and it is the mass is equally distributed. Now I am going to guess at which point the center of mass would be. The point A, another point B, and here is another point C, and here is another point D. Which point it would be? Now we can just assume the total size. Just you make like a rectangle, okay, and the center of the rectangle is here, okay. So of course the point B might be a center of gravity, right? But if you see this portion and this portion, the mass is not there here, no mass. But at the bottom portion it has mass, full of mass at the bottom. So if these locations, number 1, number 2, in these locations, if it has a full mass, then we can say the point B would be a center of mass. But here in this portion 1 and 2 there is no mass. So what will happen? The center of mass always move towards more mass region. So here is a possible answer C. The D will not be, because if you take if you just lift this object through the point D, it will not be stable enough. It will not be stable or balanced. It will not be balanced. So the point D will not be a center of gravity or center of mass. So C is a possible answer, because the center of mass always move towards the more mass region, not towards the less mass region. It will not move. Here is a balancing ruler, a small home activity. You take your ruler, 30 centimeter ruler, and you place your finger at the point 15 at the bottom here. So it is balanced, because here is the point the total mass of the ruler seems to act. So here it would be center of mass. So the ruler is balanced. We found it. Okay. Now I want to find like the earlier concept, the guessing point. I said the center of mass move towards the more mass region. I want to find out. So how can I find? You place a small coin at the left side from your finger, the left side, and here is the right. Now what happens? The ruler tilt towards the left side downwards. So now if you want to balance the ruler again, you just try to move your finger towards left side or towards the coin slowly, slowly, somewhere at the point it is balanced. So what happened now? The center of gravity no longer acts at the center. Now it is moved closer to the more mass region. So here is the center of mass now. Center of mass 2. Center of mass 1, before you place a coin exactly acting at the center 15 centimeter. After you place a coin at the left side, the center of mass is moving closer to the coin. That means it is moving towards more mass region. Here is the center of mass 2. The another example from our day life, we see the mop stick. Here this is a regular shaped object. It's like a cylinder. At the center of the cylinder, the center of mass should be, but in this case the center will not be here. It will go more closer to the more mass region. Here is a more mass, some extra fitting, so this point will move somewhere closer to the more mass region. So center of mass 2. Center of mass 1 without these threads, and center of mass 2 with the mass. Applications in the daily life. Now we understood the center of mass is not always at the middle or the center. It moves towards the more mass region, right? So here is the book rack or the bookshelf. The center of mass of the book rack, if there is no book, it seems to act at the center point. If it is equally distributed, the mass of this bookshelf is equally distributed, it will be acting at the center. Okay, now I want to move the center of mass to the top. So I will keep my books at the top. So what happens? This center of mass is now rising up. It is moving up. Now in this bookshelf, I keep the books at the bottom racks. So the center of mass will move towards the more mass region. So here, which will be more stable? Now we can identify the stability as well if we know the center of mass, the concept of center of mass. Now here center of mass rising, bookshelf it is lowering. If the center of mass rises from the base, it becomes low lower stability. Here it will get higher stability. So it is the reason we have to fill the bookshelf at the bottom first. Fill the books at the bottom, then at the middle, then at the top, so that we can keep our center of mass always closer to the base. If your center of mass is more closer to the base, the object is more stable. And the stability is not only is getting affected by center of mass, there is one more factor, that is the base area. Base area affects the stability. If the base area is bigger or wider, will have the higher stability. If it is narrower, smaller or narrow, it will have the lower stability. Another example for you for the stability. So if you want to know the which object is more stable, number one or number two. So for stability, there are two factors, affecting factors are there. One is center of mass, center of gravity. Another is base area. So let's check the base area of both objects. Here the base area is same. So we cannot decide now the one which one is more stable. So let's think about the center of mass. So find the center of mass here. Center of mass, assume here the center of mass which is closer to the base, and here the center of mass is more away from the base. Here is the center of mass. So the rectangle number one is more stable, because even though the base area is same, but the center of mass is more closer to the base. So this kind of object will have more stability. Application number two. Now we test this glass, the glass cup. Is it more stable or less stable? And then how the manufacturer do some modification to improve its stability. Here if you see the bottom, it is narrower. So center of gravity will not closer to the base, because it is narrower and it has the less mass. So what happens, the center of gravity will go higher, more away from the base. So here is a base. So center of gravity is now more away from the base. So this cup, this glass cup will not be more stable enough, because the center of gravity is moving away from the base. And what the manufacturer can do here, he will fill more mass like this here. If you see another layer in the glass cup, most of the glass cup you can see at the bottom, it is very thick, and he put more mass at the bottom. So he will keep the center of mass more closer to the base, more closer to the base. Here is another application 3 in our daily life example. Double deck bus. The passengers are not allowed to go to the top floor before they fill the ground floor. Why? Because if no one sit here in the first floor and then they directly go to the means on the top floor, and they sit here and it is crowded. So what happened, before the center of gravity was more closer to the base, because here at the bottom lots of luggages and the engine everything, so it will be more closer to the base center of gravity and it is more stable. So if passengers are allowed to go to the top without filling the ground floor, what happens, the center of gravity will rise up. So if the center of gravity goes up, rises, then it becomes less stable, and when the car turns, during the turning, it topples over. Another application, the boat. The passengers are not allowed to stand here when they are traveling by boat. The reason when they stand, what happens, their center of gravity affects, because most of the people they have the center of gravity at their belly button. So when they stand, what happens, the center of gravity rises, so it is danger. We have to maintain our center of gravity always closer to the base. So what happens, this object, any object where the center of gravity rises, becomes less stable. So the boat, the pilot will not allow the people to stand to maintain the center of gravity acts closer to the base. Application, keep your luggages at the bottom. In the olden days in the bus, we usually keep the luggages at the top. So what happens, the center of gravity of the bus affects, it will go up. So center of gravity rises up, gets less stable and topple over. So nowadays if you see the low floor bus, new modern buses, they have the cabin at the bottom. So they open this cabin here, 1 2 3 at the back, here will be the cabin. So you place your luggages here to maintain the center of gravity more closer to the base, so it will be more stable. Railway application, climbing mountain. When you climb mountain, you lean forward because you put your center of gravity more closer to the base in order to increase your stability. Other application, for the race car, it has the wider base and it is lower. It is lower in height. So center of gravity is closer to the base as the height of the car is not much. It is lower, and then the base area, the wider tires, the tire between the gap between the tires are wider, so it has more stable. So it affects the stability, the base area and the center of gravity. So both factors are considered here. So the race car can go at a maximum speed because the base area is wider and it has the less height, so the center of gravity is more closer to the base. Here is another example, the tilted bus. If it is balanced or not. So how will we know? Now first we would know the center of gravity would be more closer to the base. So the total length here. So approximately we can find the center of gravity would be more closer to the base. Okay, because the engine is here, so it will be more closer here. So now here is the surface, here is the base. So you have to draw a line to the base, a vertical line to the base from the center of mass. And if the line lies exactly into the base, the bus is stable. If suppose if the line falls out of the base, even it is tilted more, if the line falls out of the base, then it will tilt. Here in this question, the stability of a bus is tested by tilting it on a ramp. The diagram shows a bus that is just about to topple over. Just about to topple over. So if you draw, here is a base. So if you assume this, if you draw a line, draw a vertical 90-degree line to the base. Now you can see this is the base of the bus, and this line is passing out of the base. So this is already the bus is fallen, is toppled over. So this is not a point because it says about to topple over, which means the the line what we draw will exactly at the corner, at the edge of the base. So this will be the answer. The point B is the answer, because when you draw a line to the base, make 90-degree, which is passing through the edge of the bus, so it is about to topple over. Thank you very much for watching my video, and in the next video we will discuss about how to find the center of mass for two or more objects together. Example, here is a mass m1, here is another mass m2. Now these two objects will have a center of mass in between the line joining point, anywhere in between. It might be at the middle, exactly at the center point, if these two objects has the same mass. If one mass is bigger than another, then this center of mass will move closer to the more mass region, as we learn in this video. So we have some formula to find the center of mass, that is the mass multiply by the distance divided by the total mass of the object, given object. Thank you very much.